Good morning, everyone.
Good morning.
Glad to see you all here bright and early, ready to learn cool and awesome things. My name is Rocky Lotka. I'm the CTO at Magenic. I'm also, over the last 20 years, have been an author and speaker talking to people about building enterprise software using the Microsoft platforms, originally COM, of course, and then as we go forward in time, we get into the .NET world. And so our topic today is microservices and how they're going to transform the world into something that we've never seen before. Oh wait, no, that's somebody else's talk. My talk is going to be about microservices and messaging and how, in my view, this is actually another run at what we tried to do 12 or maybe 10 years ago with SOA and service-oriented architecture. And it's basically the same thing. We're just taking another run at it. And you might say, well, why would we need another run at it? We already did it, right? Everybody here is completely service-oriented, right? You know, usually, and the lights are bright, so I won't ask this, but typically, when I ask an audience how many people, how their organizations they think are truly service-oriented, it's usually 2-3 people in a room this size. And everybody else, of course, went through the whole service-oriented thing, and it just never took. And so the question that I think we owe ourselves, just being responsible, is what makes us think, here we are 10 or 12 years later, what has changed such that we think it'll work better this time? And now they adjusted the lights, which is awesome. So does anybody have any thoughts on what might be different now than 10 years ago? Deployment strategies, Docker. So basically container-based deployment. We have better understanding of DevOps, or so we like to think. The cloud. What was that about executives?
New one.
Oh, new executives. Okay. So upper management that doesn't know the failures of the past, okay? or maybe you're saying that they're better educated than the previous batch. No?
Maybe they don't have to deal with so much legacy.
Oh, so your legacy code has faded away. So nobody here has to deal with Windows Forms anymore. Okay. That was a pipe dream, and I knew it. So a lot of these, I think, are good observations, right? 10 years ago, we did not have the term DevOps. Whether today everyone has the discipline or not, certainly we at least have the idea of automated deployment and so forth. Docker is one example of many where we've come up with, and the public cloud is too, with platform as a service, where we've come up with technologies that make it easier to deploy relatively small amounts of code that might host services. And of course, update them and make them current over time, right? I would also toss in that 10 years ago, we, at least in the Microsoft world, did not have the async and await keywords. I think those are a particularly big and powerful step, because everything that we're doing when we talk about microservices ultimately ends up being parallel computing across different computers or networks and so forth. And so having the language support, at least some language support, to help us deal with asynchronous and or parallel computing is a big deal, right? So that's why I'm giving this talk, right? If I thought nothing had changed over the last 10 years, I wouldn't be here, because 10 years ago I was a big skeptic. And frankly, I still am. And the reason I am is because the gentleman mentioned executives, and then I said, oh, they're better educated, and he says, no, they're not. And the reality is that doing a service-oriented system, right, just building a whole bunch of services, testing them, keeping them in sync, orchestrating everything, is really not easy. It might be easier now than it was 10 years ago because we've got some things that have changed, right? But it's not easy, and it's not cheap. And so it's cheaper to build a monolith or an N-tier application than it is to build something that's truly service-oriented. So I think there are still some major barriers and hurdles. So before we go any further, I want to point out that in this context, terminology is really important, because what is an app to you? Right? Is an app a thing that runs on your phone? Well, to most people the answer is yes. Right? Is a browser single page app, right, written in Angular or React, is that an app? And some people might say yes, some people might say no. If you build an N-tier application, is that an app or is it an application? And if you say, oh, no, that's an application because cell phone things are apps, then I've got to ask you, well, what's the difference? I mean, where do you draw the line between app and application, right? So regardless of what you may believe, and you can go home and keep using the words you want, but for this session, we need to have a common set of language, just so we can have a meaningful conversation. Because I've heard people say, oh, well, we're going to have a service-oriented app or a service-oriented application. My contention is there is no such thing. No such thing. And this is because every service is an application. Every app, mobile or website that's sitting on the edge of your overall system is an application or an app. I personally use the words interchangeably. Right? I save some breath by using the word app instead of application, and I don't see a big difference between the two. Okay? So basically my contention is this, that you can't have a service-oriented app. You have a service-oriented system, and in that system you have many apps, some of which are services, some of which are what we might call edge, or Microsoft is now calling the intelligent edge apps, which might be mobile apps that, basically the edge apps are a type of app where either a user, a human, is interacting with your system through the app, or some other external system that you don't control is interacting with your system through the app, right? But some sort of external user scenario. The other thing that I run into quite frequently, and because I spend a lot of time talking to customers, right, or at least prospective customers, and so I get around to a lot of different organizations and have a lot of different conversations. But when it comes to microservices, one of the most common conversational tracks is that, oh man, we've got a monolith. The monolith is increasingly difficult to maintain. What we think we're going to do is just kind of break it apart so all of the methods in this monolith are services. Have you heard this or some variation on this theme? Right? And so here's your monolith. Right? It might have a web API, or an HTML API and a JSON, web API, and basically people can call into your monolith, and then your monolith is just a whole bunch of methods that are calling each other. Right? I mean, and you might say, oh, no, we're object-oriented, and I approve, right? I'm a fan of object-oriented programming, object-oriented design, but if you step back a little bit, every method and property in all of your objects are really just methods. And so yes, object orientation is a beautiful abstraction over the fact that you're calling a bunch of methods. Right? At the end of the day, this diagram is pretty accurate. And then we say, great, we're going to transform this monolith by renaming all those methods and making them into services. That's pretty awesome, isn't it? Or not, right? We gain nothing. In fact, I'm going to contend that we lost a whole ton. So how long does it take to call a method? Nanoseconds. Right? Essentially untimable. I mean, it's really hard to time how long it takes to call an empty method, right? Because it's just right there, simple. Heck, half the time the compiler probably inlined your method, so it's not even a method. Right? I mean, very, very powerful stuff. Take that method and put it in another process on the same computer. How long does it take to call it from one process to another?
Microseconds.
Yeah, now we've gone from nanoseconds to microseconds, order of magnitude, right? I mean, it's substantially, in fact, it's probably a couple orders of magnitude, right? Because one way or another, you've got to go through named pipes or HTTP or some sort of protocol, and you've got to go from this process over to this other process, right? And not only that, where here I was able to pass values by reference, because we're all in the same memory space, now I'm not in the same memory space. And so now I have to take up all the stuff over here that I think that the other method is going to need. I have to package it up through a process called serialization, which converts it into essentially a byte array. At the end of the day, it's a bunch of bytes that we're going to send over this either HTTP or name pipes or whatever it is to this other process where it has to be unpacked and converted back into useful data. And serialization is really, really not free. And now, take this and put a network boundary in between. Right, so now we're not calling on the same computer, we're just calling somewhere into the network. Now, what's the performance hit?
Milliseconds.
Now, easily milliseconds, right? I mean, even on a fast backbone, you're probably talking 5 or 7, just network latency. If you're going over the internet, you could be talking tens or even 100, you know, to go from like here to Europe is probably 170 or something, right? And so all of a sudden, every one of those method calls, if we back up a slide, which used to be basically instantaneous, are now taking, you know, measurable time every time. And look at all of the calls and the interweaving of that. So now where the user used to make one call in and a whole bunch of stuff happened and they got their result back in, you know, hopefully relatively small amounts of time, now you've got to multiply that time maybe by 1,000 or more. So we took a huge step backward. Clearly this can't be the right answer. Right? Clearly this is not. And you say, no, but what's different this time, Rocky, is 10 years ago we were creating services with a capital S. And now we are creating microservices. They are small and limber and agile and fast. Yay! Yeah, but physics is physics. Right? I mean, that part didn't change. And if you can change physics, wow, that'd be pretty awesome. Just don't do it while I'm on Earth, because I like gravity. All right. I used the word app earlier, or application. And this is an architectural diagram that I've been using for many, many years to talk about how to build software. And I think that generally speaking, almost every app out there can be described using these 5 layers. And none of this diagram implies network boundaries, right? Everything here could easily be running on one computer. But I'm going to contend that whatever app you've got has some sort of an interface, either for a human or as a service interface or something, right? When I was in university, I got had the opportunity to take what was called Landsat data. This was kind of a special project I did with a couple professors. Landsat data from satellites. And they had an old Fortran system that processed it. And I was doing a variety of things, trying to port it from one computer to another and also do some performance improvements. And what I discovered early on is that the Fortran compiler on the computer I was using was really quite clever, because I took an algorithm and rewrote it to make it what I thought was better. And then I thought, well, I'll time the 2 of them. And I didn't care about the result, so I didn't print out a result. I just checked the timing. And the algorithm went from taking a substantial amount of time to taking 0 amount of time. And I thought, wow, I'm really awesome. No, I really didn't think that. I mean, I was puzzled, right? I'm like, yes, I think I improved the algorithm, but not from many, many seconds to 0. That's absurd. And so I started looking into the whole thing and discovered that the Fortran compiler noticed that I was not printing out or displaying the result, and so it optimized away my entire program. Which, you know, you gotta think is pretty cool. But I guess my point being that if you're writing code that doesn't have any sort of an interface, you gotta wonder what the hell your code's doing, right? I mean, why are they paying you? So it's gonna have an interface. In today's world, we tend to use MVC pattern or MVP or MVVM, some sort of a design pattern that separates code from the interface itself into some interface control layer. That might be a controller or a presenter or something, right? And so the top 2 boxes do that. Probably your app does something meaningful, so it has some sort of business logic, right? I would hope so. Although people do write services that do nothing except go to the database, retrieve data, and then return it, right?
Yeah.
So let's pause and just talk about that scenario a little bit, because that's probably super, super common, and is also where most of us ended up when we tried to be SOA. Right? I mean, being actually service-oriented means that your service has business logic. It actually does something. That turns out to be hard. And so what we learned all the way back in 1996 when Microsoft Transaction Server and then COM+ and Enterprise Java Beans and Power Builder's Jaguar, all these products came out in 1996 and said, hey, you know what? What we will help you do is create an app server at the time. You call the application server pulls data out of the database and returns it to you in a tabular format. Whether that be an array or a collection or a data set or a record set or whatever you call it, right? Nobody at the time thought this was service-oriented. This is N-tier, right? You call the app server, it talks to the database on your behalf. Yay, N-tier. And so then you roll forward into the whole SOA time frame, and we get WCF and all these other technologies that theoretically let us create actual services. And what most of us did is we created the same kind of a thing where you call a service, and the service goes to the database on your behalf, gets data, and returns it to you. So now you're just using service-oriented technologies to create client-server. Yay! But it does look good on the resume, does it not? Right? I would argue that it did us harm. You know, you might say, well, this is neutral, Rocky. But I would argue that it did us harm, and the reason being this, that back in the 90s, the late 90s, all of these protocols on the network were binary transfers of data. And then when we decided to be quote-unquote service-oriented, we switched to XML, which is only about 15 times bigger than the binary data. So, you know, luckily networks have gotten a lot faster over the past, number of years. And so we don't see it, but we, collectively, all of us, chose to choke the hell out of our networks compared to what we used to be doing, right? So then we switched to JSON, which is much more efficient than XML on the wire, and it's only maybe 10 times bigger than binary data. Yay? I mean, you gotta wonder, right? All right, so my point is that if we're really talking about being service-oriented, your microservice will have business logic. It's not just some dumb thing that returns data, right? That's just N-tier. You know how to do that. Yes, go forth and be happy, but don't pretend like you're doing services. Now, behind the business layer, at least at some level, there's certainly data storage. And one of the key things with being service-oriented is that every service owns its own data. And you might read that what I just said is every service owns its own database. But that's not what I said, right? I mean, we all have to deal with the reality of large corporate databases that have existed probably forever, right? And now we're going to go be service-oriented. You're not going to tear your database apart and make it into a bajillion databases. Somebody somewhere is going to tell you that's never going to happen. It'll be an old crusty person that runs your database. Or maybe a young crusty person. It's just my point is that database people are crusty, right? And so you're not going to do that. What I'm talking about in this context is that maybe it's a table, maybe it's a set of tables, but your service owns that data. This is part of why this is hard, because today your monolith owns all of it and probably interacts kind of uncontrolled across many of your different tables and whatnot. And you're going to have to untangle that and say, no, this service is the thing that owns my inventory, or even some subset of inventory. Right? It owns a certain small chunk of tables or small defined chunk of data, and nobody else should be talking to that data directly. They should go through the service. Right? And just stop and think, right? That's not easy, is it? But that has to be the goal. Now, this is a client server. I'm going to kind of skip past it. Here's taking that same diagram and saying, certainly in my service-oriented system, I will have what are called edge apps. And edge apps, at the end of the day, that interface is either designed for humans, right, my end users, or it's designed for some other system that's outside of my system, right? But it sits on the edge of my system. Now, of course, in my system, all of my services, every single service looks like this. Right? Architecturally, it has an interface that's probably JSON these days, right? And it has business logic and it owns its own data. And if you're going to build edge apps that are possibly disconnected, right? Things that run on a mobile phone, people go outside of cell range. I'm going to flip this around, actually. People use the term occasionally disconnected, but really what I'm suggesting by this diagram is if you have to write an app that's going to run on a tablet, a PC, or a phone, and it might be disconnected, you should write it assuming it's always disconnected and that it is only occasionally connected. Right? Flip the verbs around, right? But the reason I suggest this is that we have seen over, now decades, a lot of different attempts at creating occasionally connected or occasionally disconnected applications. The ones that we know work really, really well, that are like bedrock solid, are things like OneNote and Outlook. They follow this model where the application is written always to interact with offline data. Always. Which is why when you're composing and reading email and the network comes and goes randomly, you don't even notice, right? It just keeps working. Whether you're on an airplane or in a rural part of a state where you don't have reliable network, it just keeps working, and when it gets a network connection, it synchronizes with the rest of the world. So I've talked about what a service looks like from an architectural perspective, right? It has an interface, business logic, some sort of data. But what does the actual service look like from the outside, the API, right? Now, the old style approach to this sort of thing said, you know what, and then when I say old style, I mean the stuff that came out of 1996. This is Enterprise Java Beans and Com Plus and that sort of thing, is to say, hey, you know what? Basically, these technologies let me expose what looks like a normal method with normal parameters, and I just get to call this thing, right? That's the top example here. You say, oh, I'm going to do that. That makes sense to me, right? What this is actually called is a remote procedure call. I've defined a procedure, I've exposed it to you, and you can call it over the network. You are calling my procedure remotely. RPCs have been around for 30 or 40 years. But this idea of an RPC is not new, nor is it service-oriented. Because you're not thinking in terms of sending messages. You're thinking in terms of calling methods. But in a service-oriented world, there are no method calls. It's all about sending messages across the network. And so if you're calling a method that looks like that top example, just by definition, you are not service-oriented. Cannot be. The middle example is much better, right? Notice the middle example accepts a request message or object or whatever term you want to use. You know, our tooling makes this stuff a little bit nebulous, but what really happens is that I, as the caller, right, I want to call a service, I compose a message, and in like C# and whatnot, probably my message is an object. So I create an instance of an object, I load the properties with data, and then I send it off over the network. And some technology like WCF or the Web API client or whatever it is, takes that object and converts it into a message. Right, so it's a convenience, right? We're talking syntactic sugar, that's the phrase, right? They're just making our lives nice. That message is probably JSON, but it could be binary. We don't really care, right? Do we? Right? I sent the message, off it went, and boop, 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 it goes across and it gets delivered to the method that we see in green here, right? And the technologies at our disposal take the message, parse it back together, deserialize it, and convert it into some sort of an object, usually again if we're doing C#, and then they pass it to you as what looks like a request object. But it's really a message. Now I get to do whatever I'm going to do, right? I get to do some work, whatever it is. My business logic runs, I might talk to some databases, yay, and I compose a response. Which again, to me, my response looks like an object, but when I return it, it gets converted into a message, probably again JSON, goes dot, 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 back across the network, gets deserialized back into an object, and the original caller now knows what happened. Right? Sounds pretty darned awesome, doesn't it? Except, it's still not the right answer. And the reason it's not the right answer is because it is a synchronous call. And if you really want to get the value of being service-oriented, your calls should be asynchronous. And in particular, they should be one-way messages that I, as the caller, I just send a message out, and at some point in the future, maybe I'll get a message back. And by sending it out, I send it out. What does that actually mean? Ideally, I send it into a queue. And I'm not going to get into technologies yet, right? But it could be an MQ series queue, an MSMQ queue, a service bus queue. I mean, I don't care. Ideally, it goes into a queue. And then the service implementation running in my servers is listening on that queue. And every time something shows up in the queue, I pull it off and I get the request object, which was what was written into the queue, right? That's the message that got written into the queue. I pull the message off, process it, do my thing, and if I need to send a message back, like the response message, I compose the response message, and what do I do with it? I put it into a queue that gets, sends it back to the caller. And you might say, Rocky, why is such a big deal about the queue thing? Well, if I don't do it this way, right, so I'm doing essentially point-to-point communications, like in the green example, right? I set up a connection to a URL, I make the call. What happens if the server's not there?
Fails.
I fail. Right? So now I have to deal with the failure. Right? What happens if it is there? I make the call and then it crashes. I still have to deal with the thing, but I probably won't find out it failed for 90 seconds. or whatever the TCP timeout is, right? I mean, at no point in that scenario can you give your user a very good experience. This is kind of where I'm getting at, right? At no point can you. Here's the other thing. Suppose that service becomes popular. I mean, all of us dream of writing the service that everyone uses, right? It's like, oh, I wrote the linchpin for the whole company. Woo! Job security, right? But what if you do that, all of you start calling my service, I get completely overloaded. How do I scale out? Because you're calling me by URL, right? You say, oh, Rocky, that's no big deal. I'll just go out with a huge pocketbook and buy an F1 router and a couple servers. And of course, I don't know how to set those up, so I'm going to hire some IT pro or external consulting company to do that for me, right? And so I spent a huge amount of money. And I probably solved the problem. I don't dispute that, right? Probably everybody here has encountered this and done that, right? But it's not easy and it's not cheap. And I've added extra points of failure, such as the F1 router, right? So, whoops, right? This was not ideal. But if I'm doing a queued scenario, right? So all these messages are coming in through a queue. If I need to scale up, how do I do it? I just spin up another app server node that listens on that same queue, and I literally have doubled my capacity. Just boom. How much did that cost to spin up another node? Especially when we're talking about public clouds or Docker instances, stuff like that, my cost was incremental at best. Right? Essentially, it might be close to free, or if I'm in a public cloud, I've doubled my cost, but it's relatively low. Not only that, did I introduce any new points of failure? No, not really. And if I want to be really clever, maybe when I spun up that second node, I didn't even spin it up in my data center. I spun it up in a data center halfway across the country. So now, if a tornado, earthquake, flood, fire, whatever comes through one of the data centers, does anybody notice? Well, yeah, obviously all the people that just got slammed and their houses destroyed. That's depressing. That's not where I wanted to go. But my end users might actually see a difference in that for a moment everything becomes relatively slow until in yet a third data center I spin up another instance of the processor, right, to pick up the difference in load. And so generally speaking, nobody really notices. And you say, oh, dude, where am I getting all these data centers? Well, that's what things like Azure are for, right? You don't have to build out all these data centers. You just tell Microsoft through the service, the SLA, when you set up your Azure subscriptions and services, you say, I want geo-redundancy. And they say, that's fine, it will cost you a little bit more per month. And you say, that's fine because I'll never go down. Because I don't want to be a British Airlines, right? So speaking of Azure, how and where in Azure, and I realize I'm about to commit heresy. Here we are in the Microsoft campus at a Microsoft-oriented conference and so forth. The reality is that everything I'm talking about here, other than the specific technologies, but all these concepts, the architecture, applies just as well to Google and AWS, right? So, if you say, man, for whatever reason, we don't use Azure, we've bought in heavily to AWS, that's fine. These concepts and architectures work the same way. Just their products are called something different. And my nod to Microsoft is they're probably not as good. I don't know. So, one way to host services inside of Azure is to set up a web app, which is a platform as a service concept inside of Azure, where you just basically deploy something written in ASP.NET. And the reality is that all of these method signatures can be implemented using Web API or WCF, all of which host inside of ASP.NET, right? The bottom one, though, again, if we're going to do queued messaging, the reality is that what's going to happen is you're going to send your external users are going to communicate with your Edge app. Your Edge app is going to be writing stuff into a queue that then gets picked up. So really, the web app is not the best answer here. I just list it because this is kind of the thing most people default to. Right? How many people have used web apps? Right? I mean, almost everybody. It's a pretty common thing. Now, Microsoft a while ago introduced this thing called a web job, which, generally speaking, is a method that gets called based on a timer. And its general purpose is that you use web jobs to do cleanup things, right? Every 3 hours, I need to make sure my session gets cleared out from my web server, or some old log files get truncated, or whatever it is, right? Turns out web jobs, not particularly useful for our purposes here. Even more recently, Microsoft has created this thing called Azure Functions. And they created them essentially in response to Amazon creating a thing called Lambda functions. So AWS is basically the same idea. You write a method, you indicate under what conditions do you want your method to be called, and like a message arrived in a queue, or an image got changed, or a file got changed. I mean, there's a whole host of triggers, but basically you say, when this trigger occurs, run my code. Right? So Azure Functions, in my mind, are really pretty darned awesome. Because I write this method, I don't have to write all the plumbing for why it gets called. I don't have to write listeners for queues. Microsoft does all that for me. Right? And when an entry shows up in the queue, my function gets called. Right? And so web functions are actually pretty powerful. I strongly recommend looking at them. With the new release of Visual Studio 2017 that came out this week, now they've got support in Visual Studio for creating Azure Functions. So it went from being a relatively manual process where you had to know a lot to being a normal process for us Microsoft developers, because now it's in Visual Studio. There's a nice little creation wizard. There's IntelliSense, the whole 9 yards. Right? So definitely look at Azure Functions. Azure Service Fabric is, well, ultimately what Azure Service Fabric does at a base level is provide some level of orchestration for resources that run in the cloud inside of Azure. And Microsoft has built a lot of their stuff on top of Service Fabric. So if you run a virtual machine or run a web app or any of those things, most of what we've talked about, you're actually using Service Fabric. Well, Microsoft is using Service Fabric on your behalf. How's that? At some point, Microsoft said, hey, you know what? We could let all y'all use Service Fabric directly. Then you can do your own orchestration. And so with Service Fabric, you can orchestrate spinning up virtual machines or Docker containers or a variety of different things. It's a little less abstract than Azure Functions, but it's potentially more powerful. And then finally, we get to the bottom, which is Docker. And Microsoft's got several different ways to host Docker. The most recent and the one that they're very excited about is the one that I've listed here for container instances. It's basically an orchestration model to spin up and down Docker instances for you. Now, several of these are what are called serverless computing, which is a horrible word, right? Because it's not like there's not a server. Of course there's a server. It's just you don't manage the server. Somebody else does. Microsoft does in general. Yes?
Can the last two be a WIM format? Does it have to be a console map? Can the last two be a WIM format?
Oh, can Azure Service Fabric and Docker containers be a Windows Forms app? Not in this context. So the advantage of these serverless ideas is that you don't have to set up a virtual machine, you don't have to install the operating system, you don't have to do security patches. All those things get delegated to your cloud provider. I get very excited about this. Primarily, and not like IT pro people are bad people in any way, don't get me wrong. However, IT pro people like to do the best job that they can, just like us. And my experience is that very frequently the way that manifests is that the night that we're doing a deployment is the point that they decide to throw in an extra optimization that nobody ever discussed. Right, so Friday afternoon, we hand over all of our code assets. Saturday, they're being deployed. I'm at home on the beach, sitting there having a barbecue. And then you get this emergency panicked cell phone call because my code didn't work. And hours and a sleepless night later, you discover my code worked great. It was that somebody had, during deployment thought, oh, I could optimize this security setting, which of course broke my code. Now, whose fault was that? We don't know, because those server configurations are not in source control, right? Now, all of this stuff is either pre-canned and we don't even control it at all, or in the case of Docker, the Docker definition files, what are called Docker files, should be in source control. So it can still be the case that somebody does one of these optimization tweaks at the last second, but for them to actually make it happen, it had to go into source control. So at least we know whose fault it was. And most importantly, that it wasn't mine. Just saying. So I assume everybody's read or seen the term serverless, right? There's no magic here. That's all it is that somebody else is managing the server for you. You get instances of runtimes to run your code. That's all we're talking about. In my mind, the more abstract, the better. So I really like Azure Functions, and I really like Docker containers as being hosts for my code, right? In both cases, these things are designed to spin up essentially instantly, run my code, and then disappear. Right? So the overhead is very low, the consistency of the runtime is extremely high, and the manageability is not only high, but it's somebody else's problem. So before I go into messaging, any questions so far? Does my narrative make sense? Does it seem like there is in fact a challenge here? Yes, sir.
How do web applications fit into service-oriented architecture?
So the question is, how do web applications fit into a service-oriented architecture? And they are a type of edge app. There, I'll go forward one slide. So, for example, the diagram with the end user up there, that could easily be a web server and they're using a browser to talk to you, right? I mean, at the end of the day, I have a lot of control over what's inside the big circle, right? My service-oriented system. And this is somewhat, in my mind, this is not controversial, but it is, right? And that is that people say, oh man, one of those services, I created the service, I want external users to be able to use it and internal users, right? I want to reuse my service. I want all you guys to be able to use it and all of my internal people to be able to use that same service. I don't want to have to write it twice. Have you heard this conversation? Is that a good idea?
Depends.
It depends. Very, very political. Right. You're going to run for office soon, aren't you? I don't think it depends. I actually think it's a bad idea. And I think it's a bad idea for the same reason that having everything in an object be public is a bad idea. There's this idea of controlling what the external world sees, which might be different from what the internal world sees. There's also this difference that inside my organization, I want to be fast and agile, right? And my external consumers, almost guaranteed, are not going to be as fast and agile as me. If I want to be able to update my services on a weekly basis or every 2 weeks based on sprints, right? Am I really going to tell my external business partners that they'd better plan on updating their stuff every 2 weeks also? I don't think so, right? I mean, just my company, Magenic, skipping the consulting piece, we use a lot of services from our partners. That's a pain in the butt. I mean, I don't know how many of you guys have tried calling into the services exposed by like ADP, the payroll company, or recruiting software, a variety of other software as a service out there. It's never easy. You would think they would make it easier, but they don't. And you would think that they would actually run some quality control against their service APIs, but apparently they don't. Right? And you would think that they would keep their documentation up to date, but usually they don't even have any. So I guess that's one way to keep it up to date. But what I'm getting at, right, so I'm an external consumer. I hope that internally they're revving their stuff and fixing bugs quicker than they are changing their external interface. Right? And so what my point is that bottom one where it says external app, right? That's all my external users. I have created a public interface for them. Right? Probably using RESTful technologies and all the other buzzwords that are super awesome, right? And I can version that independently of all of the things that I'm versioning inside my system. I think that benefit by itself, to me, is so tremendous that I just think it's a horrible idea to say, oh no, actually I'm going to lock this service that I rely on, and so I can't change it very fast because I'll break external users. Yep. All right. So I have mentioned numerous times that if you're going to be truly service-oriented, you don't call methods directly, that you send messages between all of your different services, right? And that implies then that you understand messaging. Now the good news here is that messaging is a very old science. Mainframe developers 30 and 40 years ago figured out really, really good patterns for messaging because mainframes at that time were extremely limited computers. And so even inside the same computer, they had to hand off processing from one thing to another or queue up work just to make it possible, because sometimes the jobs they were trying to run would exceed the amount of RAM in the computer itself. So people figured out messaging patterns a long time ago. Or go talk to Disney. Because an awful lot of messaging patterns turn out to reflect the same kind of patterns when you're trying to deal with humans. If all of us are messages and we're trying to all go get on the most popular ride at Disney, Disney has figured out really great ways to deal with all of us. You follow what I'm saying? Right? Queues and all sorts of other schemes, fast pass tickets, right? Those are just priority tickets that get delivered for some messages. I mean humans, right? What I'm saying is that there's a lot of science that's gone into messaging. We don't need to reinvent the wheel. This particular book that I've thrown up here, I really like a lot. It's not a, it's a patterns book, right? So it's not a tutorial. It's not going to walk you through how to do these things. But when you encounter a problem and you're like, gee, I wonder if anybody ever encountered this before, this book probably has the answer. So here we get back, excuse me. Here we get back to my original ARG picture, right? We took all of our methods, we converted them into services. Now we've got a mess, a really slow mess. There's got to be a better solution. And there are two things here that I'm going to talk about. One is that, again, we're not going to do point-to-point messaging. We're going to use queues to do all of our message delivery. Luckily, you don't have to do queues all on your own. There's a technology called a service bus. So if you're inside of Azure, for example, there's the Azure service bus. If you say, oh, we can't use the public cloud there's a whole host of other things that are either commercial or open source. So Apache Artemis, for example, is a very well-regarded open source queuing system. Strongly recommend looking at that. But you can also look at things like RabbitMQ or NService Bus, which are products that will run in your data center, right? And then you actually pay somebody to have a throat to choke. So it depends on your perspective. But the point being, you end up with a service bus and everybody talks to the service bus. And let's be fair, right? The first time I ever heard about service buses, I thought, wow, that's probably big and complicated and scary. But it's not. A service bus is just a centralized collection of queues. And each service bus vendor does things a little differently and so forth. But at the end of the day, basically what we're talking about is that the service bus allows you to put messages into queues that then get picked up by other actors or other agents or services or whatever term you want to use. If you're going to go down the service-oriented road, in my view, you have to have a service bus. So the other thing, and I don't have a good slide for this, I haven't figured out a visual, but let's talk about the other big thing that gets us from this picture of chaos to this picture of at least some order, and that is, how big is a microservice? As big as it needs to be?
As small as you can get away with?
As small as you can get away with. Well, that sets some boundaries. Right? Smaller than the old service. There's a good one. There is no answer. Here, you have...
Well, I think it's got to be self-contained to be deployed.
Now we're getting something, I believe, concrete. Thank you, sir. So there is no right answer, at least not that I've ever seen, or in my view, there's not. So all of these three answers are actually pretty darn good, right? But this answer, which is that it has to be of a size that I can deploy it, and that it is self-contained, and the term you want is actually autonomous, right? So the service does everything it needs to do, and it's something that's a deployable unit, right? Those are critical. The other thing on the minimum size, as small as it can be, right, or smaller than the previous service, that's fine, but remember that when you call a service, as the caller, you're taking a message, packing it up, getting it serialized, not free, putting it into a queue, not free, and then somebody over here is listening on the queue, pulls the message off the queue, not free, deserializes it, not free, and then processes it, right? So all that not free stuff, right? That's overhead. You can add that overhead up. You can actually get some reasonable measurement of the overhead in serializing a message, putting it on a queue, taking it off a queue, and deserializing it. So whatever that overhead is, your service had better do enough work to have been worth the overhead. Right? So if all your service does is some mathematical calculation that takes nanoseconds, there's no way, just simply no way, that you can justify the overhead. Right? There are other ways to reuse code. You know, there's these crazy weird things called DLLs. Right? You follow me, right? Just because we want to be service-oriented doesn't mean we blindly throw away working solutions to existing problems. There are other ways to share code, if that's your requirement, right? So my point is that, yes, as small as it can be, but the size had better be big enough that it was worth all of the overhead to get the message there and the message back. Otherwise, all you've done is tanked performance, right? Now, as big, what was the phrase? Something about can be as big as it wants, and that's true too, right? The word, this is the problem with the word microservice. I don't like the word, Because micro, I mean, what the hell does that even mean? Right? This service could be big. I might be wrapping an old legacy mainframe or AS400 system, right? Which might do a lot. It might be massively huge. And I might be exposing some subset of its capabilities as a service so that it fits inside of my service-based system. So is my service micro? This gentleman's saying no. But is it wrong? No, it's not wrong. I mean, what am I going to do? Spend $40 million rewriting the mainframe system? Right? The people that wrote that thing retired and/or are dead. It's not as though we can ask them for requirements. They're gone. We're just going to wrap it. Right? And this is going to happen increasingly over time, personally. Right? Any thoughts on that, on the size of a quote-unquote microservice? Yes, sir.
I agree. I hate the name. Microservices. It's buzzwords, right? It's almost like it should be isolated services or single responsibility services or something in that neighborhood, because microservices doesn't mean anything. It's exactly the same as a service, but implied to be smaller. The concept is good, but the naming is very confusing, and me and my team had a real hard time getting used to that at first when we started implementing. We still do, honestly, because it's just, like you said, it doesn't have to be small. It has to be focused, right? It has to be.
Yep. So the gentleman's comment is just that he also dislikes the term microservice. They should be called isolated services or atomic services, or he threw out a couple other terms, but yes, and that's the key. And you'll notice in my talk, I haven't used the term microservice all that much, because I think it's a meaningless buzzword term, right? And that's okay, right? People like IBM need to make money by selling $200 and $300 an hour consultants to tell us how to do these things. But I'm sure there's an IBMer in here now that's pissed at me. I'm sorry. So now Azure, and like I said, right, there are N Service Bus, RabbitMQ, Apache Artemis. There's a lot of options for doing messaging not in Azure, but I'm just going to run through the Azure ones because, again, we're at the Microsoft campus. But somebody up here, yes, sir.
Yeah, in your previous slide, in my mind, you're putting a lot of dependency on this messaging queue. So if this messaging queue system goes down, you're hosed on every system, right?
So the gentleman's comment is that in this diagram, I'm putting a huge dependency on the service bus and the queues it contains. And so if the service bus and those queues go down, everything goes down. Is that not true? Yeah, that's true. And you might say, well, Rocky, that's got to be a better answer. And that leads us to this slide. And in particular, again, it comes back to how much money are you willing to pay. Just like fault tolerance is just a function of money. That's all it is, right? The more money you spend, the more fault tolerance you can have. And in the case of something like Azure Public Cloud, you can tell Microsoft that you want your service bus to be geo-distributed. So, which is not to say that it still can't go down, but it is to say that for it to go down, multiple Azure data centers geographically would have to go down, right? And you might say, well, but that's happened. It happened last year when Microsoft updated some faulty certificate and literally all of Azure went down, which it did, that's true, right? And so, and then they did a retrospective and figured out what happened and wrote up some policies and procedures to hopefully make sure that never happens again, right? And you might say, well, it happened once, it'll happen again. This is a bad answer. And I'm with you, and I understand that you guys, each individually, your organizations employ IT pros and have a budget to set up geo-redundant data centers that are better than Azure. Or not. And some of you might, right? I get that, right? There's probably 1 or 2 people out here right now who are like, actually, my company does have that, you know. But most of us don't live in that kind of luxury, right? And so the odds of any of us actually having the infrastructure, deep pockets, and skill to set up global geo-redundant data centers is pretty small, which is part of the reason the public cloud is so darned attractive, right? Now, if you don't pay Microsoft the money, because you get this choice, and do you want to be geo-redundant? And if you say yes, they say, well, we will charge you more money, at which point some bean counter somewhere goes, oh, we're not paying that money, right? Then if the data center goes down and your entire company or system or site or web, whatever, goes away, to this gentleman's point, then just remember, CYA memos, right? It was the bean counter made us do it, right? Because that way, at least, you'll have, even as you're being marched out the door, you have the satisfaction of, am I cynical or what? All right, so the big dog answer is actually the bottom one on this slide, which is use Azure Service Bus, right? However, there are cheaper alternatives. Probably one of the most common is the one in green, the thing called Azure Storage Queues, which doesn't give you all of the orchestration and management of a service bus, but it does give you a table-based queue that you can write messages into and then trigger to read messages back out. So everything I've told you that you can do on top of that. That option doesn't give you as much ease to get geo-redundancy, doesn't give you as much administrative capabilities, but it's cheaper. Right? So these are all business decisions at the end of the day, right? And of course you can roll your own queue, because at the end of the day, a database table can be a queue just like anything else, right? That's arguably even cheaper, but now you've got dev cost in order to actually implement your own queue. To me, that seems kind of silly. I don't think that's a good answer. But different organizations have different attitudes toward money, right? Well, I'll just throw some developers at it. They're free. Right? I don't know. I don't feel free. All right. And so beyond that, and this really kind of starts to step up the level of abstraction a little bit. And this is not the focus of my particular talk. However, if you say, well, even after looking at things like Apache Artemis or the service bus inside of Azure, it feels like I'm still doing too much work. I still have to create queues. I still have to set up listeners or whatever it might be, right? Isn't there something that abstracts it even further? And the answer is yes. There are things called actor frameworks. A couple of the more popular ones inside the Microsoft space is Microsoft's own Project Orleans, and then an open source-ish thing called Akka.net. And what actor frameworks do is they allow you to write your service code, just like we've been talking about. You write your service as a method. The method gets called based on a trigger. You do your work, and then you send your response back into a message routing, right, service bus. Except in an actor framework, all of the management of the service bus, of message queues, of message routing, all those things are managed for you by the actor framework. So what you write are no longer called services, they're called actors, which is a pretty subtle difference, but you are still writing a method that does some work, right, at the end of the day. But now it's your method's contained in something called an actor, and you don't manage the creation or destruction of actors. The actor framework does that. Nor do you manage the naming of queues or message routing or anything. Because again, so basically, if I need to call some sort of a service, I sit over here and I go, here's my message. I construct a message, and I know the name of the service I'm going to call. And so I say, hey, Project Orleans, here's a message, send it to the service XYZ. And I don't know what happens, but magically over here, an instance of service XYZ spins up, gets the message, does some work, and then says, oh, yeah, here's a result. And hopefully in your message you told it who you were, right? A reply to address, right? And so the response, I construct my response message, and I say, hey, Project Orleans, here's a response, return it to caller ABC. And I don't know what happens, but back over here, caller ABC gets spun up and gets delivered the message. Right? Basically, they've abstracted away the stuff that you might have to write by hand if you interact with a service bus. So it kind of depends on how much magic you want in your life, right? Or how much dependency you want to push off to a vendor, right? Some organizations are like, oh, hey, that sounds good. I'm going to, some of you are jotting notes. You're going to go home and look up Project Orleans and Akka. Good for you. Others of you are sitting out here, arms crossed, going, oh, that's too much magic for me. I need a little control over what's going on. Well, good for you too, right? Different organizations have different cultures, hence there are many options. Right? Now, one of the things that I just talked about, and I'm going to actually draw just a little, or write a little bit of pseudocode here is what I'm going to do. Yes? What's that? Where does Service Fabric fit in? Service Fabric, I should put that on this slide because Service Fabric has its own actor framework. That's true. So Service Fabric can fit right here. Right there. Much better slide. Thank you. All right. Now something though that I just mentioned, and I want to dwell on this a little bit, and that is that when I did, and this is pseudocode, right? But let's just say, instead of class, let's reinforce pseudocode, right? I know there's no such thing as a message.
Now there is.
Now there is. Thank you. I feel much better. I've been arguing that there should be for some time, so now there is. And my message, I'm going to send in an int x and an int y and a string operation, or whatever, right? Whatever it is that I need to send to my service, right? This is the message I'm going to be sending. And one of the things that frequently comes up in these conversations is, well, the service API basically says I'm returning nothing because I'm accepting one-way messages, right? Redirect airplane, right? That's what I'm calling, right? That is, in a sense, that's where I'm sending my messages to something that does that, right? And I want a response, right? And of course, the easiest, again, we come back to, well, the easiest way would be that. But now we've switched from asynchronous back to being synchronous, which I'm arguing is a bad idea. So we want to leave this way. And then in this method, this service, it's going to do something useful. And then it's going to send response to caller, right? This is usually a point of disconnect when you start thinking about this asynchronous messaging. It's like, how does that happen, right? Well, if we take Azure Service Bus as an example, what happens is that in your message, you probably say reply, reply Q, and int caller ID or something like that, or maybe even make it a GUID because you just want your life to be easy. Right? There is no magic here. Right? If you want magic, that's why you go to an actor framework, because they actually do this stuff for you behind the scenes. But if you're living in service bus land all by yourself, then what you want to do is say, hey, I as the caller will be listening on a queue named this, and somehow you can identify me, right? And the way I always think about this, the metaphor is, does anybody still use the US Post Office? Right? But back when we did, we would send, up at the corner of your envelope, you would put a return address. And that way you send a letter, and then if whoever got your letter could eventually send you a letter back because they knew where to find you, right? This is the return address in the upper corner of your envelope, right? It's not that hard, right? And so what that means is that now I actually have the ability to, say message bus dot send reply queue caller ID response or something along that line, and my life is pretty easy, and the thing got written back to the appropriate queue that the original caller is listening on. And I just thought it was important to walk through that, because that's a point that usually just trips up, mentally. It's like, well, that's kind of hard, but it's not hard. It's that easy. Right. Now I've got like 2 minutes left, and so go ahead, sir.
Quick question. Would you say it's good to have a queue, per queue for all of them? Because sometimes it's very difficult to have multiple consumers all in the same queue.
So the gentleman's question is, would I say it's better to have one queue per caller, or to have one queue and then use what I'm suggesting here with a caller ID? And it depends very much on the underlying queuing technology, right? Some queuing technologies make it very easy to filter what's in a queue, and some of them don't. And so if you're in one that makes it easy to filter, this is a good plan. And then the other piece of this is that you have to look at costs. If you're in some sort of a public cloud-based environment, are they charging you per queue or per message, or, right? So, sadly, there's not a universal answer here, but the concept is what I'm trying to get across. Somebody said something?
Topics.
Oh, yeah, in Azure, you might use topics with subscriptions. Yep, and they do provide nice filtering, so. Yes, sir.
So you probably missing some sort of request ID because of the response you need to specify what you respond.
Yes, the gentleman's point is I might need what he's calling a request ID, what a lot of things would call a correlation ID, but you might also call it a request ID, but basically some way for the caller to understand which of its messages was being responded to. Yep. So again, all things that actor frameworks do on your behalf, but all things that you have to think through if you're going to do this, by yourself directly on top of a service bus. All right, at this point, I believe I am out of time. And I have a thank you slide, so there we go. All my code will be online. No, I jest, obviously. But seriously, I appreciate you all spending the last hour or so with me. I hope this was educational, entertaining, and that you're able to go out and either choose to do microservices and do them well, or choose to not do microservices because what you're doing now works great. Right? Thanks.